Hi, everyone, and welcome to this science chat on NASA's New Horizons mission to Pluto and beyond. We're inside the New Horizons Mission Operations Center at the Johns Hopkins Applied Physics Laboratory. We're counting down to what's going to be a truly historic event. In just over 100 days, the New Horizons spacecraft will add another chapter to its remarkable story with a flight past a Kuiper Belt object nicknamed Ultima. Now, that flyby on 12:33 a.m. Eastern Time on January 1st, from 4 billion miles from home, will be the farthest planetary encounter in history. Now, before then, we're going to check in with the team and take your questions on what's happening with New Horizons as we lead up to this event. So with me here in Mission Operations is NASA Chief Scientist Jim Green, New Horizons Mission Operations Manager Alice Bowman, the mom, from the Applied Physics Laboratory, and coming in from Boulder, Colorado, is New Horizons Principal Investigator Alan Stern from the Southwest Research Institute. So we're also going to be taking your questions. If you're joining us on Facebook, please submit them, and we'll get them to the panelists later on in the program. But Alan, we're going to start with you first. I mean, the world met New Horizons in July 2015 with the Pluto flyby, which was incredible. But now we're on to the next flyby, like we said, the next chapter. Fill people in on what New Horizons is going to see and really where it is. Where are we going?
Well, first, let's talk about the architecture of our solar system. You know, I think everybody knows the 4 terrestrial planets, Earth, Venus, Mercury, and Mars. They're all crowded down close to the sun. Then beyond that are the giant planets, Jupiter, Saturn, Uranus, and Neptune. And we always knew about Pluto since the 1930s, but what we didn't know until the 90s, really, was that Pluto was just, its discovery was the harbinger of our knowledge now that there's a whole third zone to the solar system. Beyond the orbit of Neptune is this vast region, bigger than everything else. There you see it, called the Kuiper Belt, named after Gerard Kuiper, who first postulated that this existed. It took until the 90s for technology to be able to find it. And Pluto is the biggest and the brightest of a whole sea of objects formed at the birth of the solar system, the whole third zone of the solar system, as I said before, which New Horizons is the first spacecraft to explore. We're 1 billion miles beyond Pluto now, traveling at 32,000 miles per hour, 24/7, on our way to make the first flyby of an object out in the Kuiper Belt, and we're going to do that on January 1st. We're going to zoom right up to it, image it, find out what it's made of, find out if it has moons or rings, and lots more about it. And that's just 100 days away, as you said.
Writing down here. So even just a few hours ago in this room, right, Alice, you were talking to New Horizons, you know, trading signals back and forth. The spacecraft came out of hibernation, came out of electronic rest, essentially, for the last time before the flyby in June. Mm-hmm. And you've been busy since. The team has been working on it and communicating with the spacecraft. If you could tell us what's happening on board New Horizons, maybe over the next few weeks or leading up to the flyby.
Sure. When we woke up in June, we did some system checkouts. We performed some software updates that we needed to support the flyby. And in August, we transitioned the spacecraft into a mode where we could take pictures. So we are taking pictures now of Ultima Thule. We call those optical navigation measurements, and we're using those to target the object. And we're also doing observations of distant KBO objects. Today, we got down some data from an object called 2011 JY31. And looking a little bit forward, we are preparing for a path correction, a trajectory correction maneuver. And that will happen October 3rd. And these optical navigation measurements that we are taking will feed into that solution.
So that's what we're talking about, being a way to essentially move the spacecraft in closer to its target, you know, as we're seeing the spacecraft too. Well, speaking of New Horizons, right, and Alan had mentioned that we're humming along in here, it's speeding toward Ultima. So where is the spacecraft today?
The spacecraft is about 80 million miles from Ultima, or about 3.9 billion miles from Earth. And at that distance, it takes a signal from us in mission operations a little over 6 hours to reach the spacecraft. And then anything from the spacecraft takes that long to get back to Earth. So we call that a round trip light time. So it's about 12.25 hours when we reach Ultima Thule.
So we're talking about, I mean, when we say the light time, that the speed of light is that signal
Yes.
moving, and it's still 6 hours to come back to us here. Alan, Alice had mentioned, taking these optical navigation and these OpNavs that we're getting from it. I mean, New Horizons can already see Ultima, which, I guess by itself is pretty cool, but that's also pretty important, too, that we're able to see this target already from this distance, right?
Mike, it's hugely important because we need those optical navigation images in order to be able to home in. It's just a dot in the distance, but finding it against the star field lets us home into the exact arrival time and arrival place that we need to find Ultima to arrive on New Year's Eve and New Year's Day. There you see it in the crosshairs. This is an image made from almost the same distance away from Ultima as the Earth is from the sun. Imagine that. This little rock, just the size of a county, which we're seeing from this great distance in these images, is what we're homing in on. And we use these images not just for navigation, as I described, but also to look for moons and to look for rings that could pose a hazard, and that we also want to study scientifically. And so these images are very important. We started that in August. We've continued it this month in September, and we'll be doing it all the way in and using our navigation team and our hazard team to check those images week by week and fire the engines, as Alice described, to keep homing in, to be precisely at the distance that we plan and precisely at the moment of arrival that we need to in order to get all this right on that flyby on New Year's Eve.
Most people are familiar with New Horizons from Pluto. I mean, that was probably the last time most of the audience was in this room, right, and saw the activity that was happening here. And the operation just to get to Pluto and all that happened here. But I guess operationally, Alice, how different is the Ultima flyby from the Pluto flyby?
Well, the first thing is that this object hasn't been known to us for very long. It was discovered in 2014, whereas Pluto was discovered in 1930. So that means that the orbit is not very well characterized, and that's why we're doing optical navigation measurements continuously, looking to make sure we know, the point in space that we want to target. It's also much smaller than Pluto. It's about, we don't know how big it is. We don't know really the shape of it, but we think it's about 23 or so miles in diameter. And as Alan said, it's in a region of space that is against a very heavily populated star field, so it's very bright. Mm-hmm. And we are trying to fly by much closer to Ultima Thule than we flew by at Pluto. So we want to go to a very small object. We want to fly by at about 2,200 miles. And we don't know a lot about it. So those are challenges in a nutshell.
Other than being able to use just we got that dark. Mm-hmm.
Can I chime in?
Absolutely.
Everything about this flyby is tougher. As Alice described, Ultima is much smaller. It's much further away from the sun. The lighting levels are lower. On board the spacecraft, it's 3 years older. Its fuel levels are lower. Its power levels are lower. It takes longer to communicate back and forth to the Earth. The navigation challenges are tougher. Everything about this is more challenging. And we think that we're up to it as a team and as a spacecraft. We were designed to do exactly this, to go exploring beyond Pluto. But it's going to be an adventure. And on New Year's Eve and New Year's Day, we're going to find out just how Ultima was born, what it's made of, what it looks like, and come and enjoy that scientific adventure with us.
Right, spending your New Year's with NASA, right? If that works.
Spending your New Year's Eve with NASA and your Christmas in the Kuiper Belt.
Jim, I'm hearing from the conversation here, right, in terms of exploration and then even inspiration, the Pluto flyby was absolutely amazing.
It was.
So we're farther out now, but how do you build on that opening act?
Well, it's really pretty easy because this has all the elements of an unbelievable set of discoveries that are just outside our reach at the moment, but will come into view soon. It's event-driven. We know we're going to fly by January 1st. That's a given. It has the excitement of what are we going to see? This is a new object. It's a building block of these larger Kuiper Belt objects, unknown to us to now. In addition to that is personal stories, what it takes for this team to make this happen. And it has risk associated with it. Are there debris in the way? Will the spacecraft make it? I mean, you know, you can't get any better than that, and it breaks the records every time. So go, New Horizons.
Every picture, every maneuver,
Wow.
everything we do
Yeah,
does
you get
it.
spectacular images on top of it. What's not to like?
So exploring this part of the solar system, right? You know, we've talked about going to we've gone to the planets, and we've seen others. The Pluto flyby sort of capped that reconnaissance of the classical solar system as we know it.
It did.
Felt the importance, though, of exploring this part of the solar system. Alan had mentioned, too, this was a region that we didn't
Right.
even really know about
Right.
20, 30 years ago.
Correct.
How important is it to explore this part and, you know, tying it to the rest of what we know about
Well, many of us in our lifetimes didn't know about this region. It was theorized in the 50s, but it was only in the 1990s that we started finding the Kuiper Belt objects. Then we could put the pieces together that this is a debris left over from our initial cloud collapse that created the solar system. I mean, we are going back in time by going out to the farthest reaches of the solar system to really understand what these objects are like. I mean, this is just tremendously exciting for us.
All right, so I'm going to start, I'll go out to some questions that we have from the Facebook audience, and you can all chime in on some of these. Some might be directed. Others, though, I think you may all have opinions on them. This is the first one. It's going to build on what you just said, Jim. So this is from Kenny Arnold, who wanted to know what we expect to find out about Ultima and how would it change your views of the solar system. So, Alan, you want to start off with that one? I know you don't like to make predictions, but...
Well, we know that Ultima is an ancient building block of small planets like Pluto and big planets like the Earth and the others. And we've never been to anything like this. It's in a deep freeze, 4 billion miles from the sun. The temperatures, you know, the light levels are so low that the temperatures correspond to almost absolute zero. Temperature out at Ultima is probably only 40 or 50 degrees above absolute zero. So Ultima's been in this tremendous time capsule, this deep freeze, over all these billions of years. And in effect, it's going to it is like making an archaeological dig into the history of our solar system. And what we want to find out are, what are these objects made of? How have they evolved geologically? How were they built to begin with? Do they have swarms of satellites? Do they have rings? What's orbiting with them? All those questions are open to us. No one's ever been to anything like this, anything this far from the sun, anything this pristine. It's been kept in this deep freeze so long. And so it's really an adventure of exploration.
Okay, anything, I mean, you know, we do know a little bit about Ultima already, right? Can you tell us a little bit about how we know what we already know about it?
Well, the little that we do know comes primarily from the Hubble Space Telescope, which NASA launched in 1990. Hubble is how we discovered Ultima. Hubble is how we determined its orbit, determined its brightness. And then we've also been able to spot it a couple times as it made stars wink out, very briefly in 2017 and then again this year in 2018. That's helped us determine its size, its reflectivity, which is about the same as garden variety potted dirt, you know, that you put in your garden. It's very dark. We know that it's reddish. We got color measurements from the Hubble, but we know very little else about it, whether it has moons or rings, what its geology is like, what it's made of, and all the other things that we want to learn are still in our future. It's just a dot in the distance, but on January 1st, it's going to become very real. We're going much closer than we did to Pluto. We're going to get even higher resolution images to see its geology. We're going to get higher resolution spectra to learn not only what it's generally made of, but it's what its different surface units are made of, to search for moons and rings, as I said before, even to look for an atmosphere. And all of that is ahead of us, but not very far, just 3 months in our future.
So there was actually a question, I love this one, from Brian Dearman, who just plain asked, so what's the big deal with this rock? So I think we're answering that question of what this would turn into in this case.
Wow, it's a big deal because we're going 4 billion years into the past. This object, Ultima Thule, was formed at the origin of our solar system. and it's been in this deep freeze ever since, as I said before. And nothing that we've ever explored in the entire history of space exploration it has been kept in this kind of deep freeze the way that Ultima has. So it's our best window into the origin of the solar system and into our own past that we've ever had. It's amazing.
You know, from my perspective, I think that question is thinking more like about the asteroid belt, which is a very different set of material. And Ultima Thule will have ices on it. You know, it'll have some of the traces of the original collapsing cloud. You know, and that makes it so much different than any of the rocky objects that we will see in the asteroid belt.
Alice, I'm seeing a couple of questions that are coming in just phrased in different ways. And again, I'll encourage everybody too. You can also ask questions in the comments section of the Facebook page under the broadcast, because we'll get them just as well. But there were a couple of questions in here, Alice, asking about the timeline of what's happening during the flyby. And I think we actually have a graphic of the flyby timeline itself, of the days leading up to and just after the Ultima flyby. So maybe take us through maybe 2 days before to a couple days after what's happening.
Okay, I'll step back a teeny bit there. Our what we call the core load or sequence of events actually starts on Christmas Day, December 25th. And that set of commands will go for about 9 days out to early on January 3rd. And so, and with the closest approach on January 1st, just a few minutes into the new year, what we are doing the days prior to that is continuing to downlink the optical navigation measurements, which will give us an idea of whether or not we are off what we call our aim point. And at this point, we don't have any more course corrections or trajectory correction maneuvers that we're going to perform, but we do have a few tricks of the trade where we can, if we see that we are a little bit off from that aim point, we can uplink a time offset along with some ephemerides and adjust when those observations take place on Ultima Thule. And the reason why this is important is because the object is very small, and as Alan mentioned, the lighting conditions are very low, and so we want to get as close as possible to that aim point so that we get that best scientific data. So we'll be bringing down that optical navigation data, turning that around into commands to the spacecraft, uplinking them to the spacecraft, and adjusting those observations by a time offset if we need to. And then the spacecraft will go on and collect data. Our spacecraft cannot be in communications with Earth when it's taking scientific observations.
Yeah, I think that's important for people to know, because we do get asked from time to time, you know, when do we see the pictures? And I think there was a bit of a surprise at Pluto, people tuning in to see like a live picture of Pluto from 3 billion miles away, but it's not that simple. We essentially have
before the flyby, so we have something on the ground before we fly by, so we can see what it sort of is going to look like. But we have a very small amount of data that will come down about, let's see, 7 or so hours after the closest approach. The spacecraft will turn and send 15 minutes of data back to Earth, and this data will not have images in it, but will have health and safety data of the spacecraft, just sort of like what we saw on the evening of the 14th.
It tells you it made it through.
It tells you that we survived.
Yeah, right. I mean, that's the idea.
That's
I mean, that's the one we're
wanna
waiting for to see, right? That it got the goods too. We're waiting for that part as well.
So that'll be on January 1st, and depending on how much we adjust those observations on board the spacecraft, it will be anywhere from 10 in the morning Eastern to 11 in the morning Eastern time.
You know, what's really remarkable about this mission is all the hard work that has to go into it prior to these encounters. I mean, it's unbelievable. You know, you got to be pointing the camera at the right place, and the object better be there, okay? It can't be off. And when you think about it, we only really know where these objects are after you watch it for one orbit. You know, Kepler will tell us, here it is. But we don't have that.
We don't.
You know, the op-nav images are just so critical to make that happen.
Definitely.
Thank goodness you had Pluto to practice on.
Yeah.
Yeah, I was just going to add to what Jim said. You know, this is all happening by remote control with a computer program that Alice's team bets out and practices on our mission simulators. We only have one shot at it. We're going by at 32,000 miles an hour, as Jim described. It's very challenging. And this computer program that runs the entire closed flyby beginning on Christmas Day and lasting for 9 days has to work. Every piece of it has to work, for pointing the cameras, to pointing the spectrometers, to returning the data back to the Earth. Every single bit of this is carefully scripted and practiced in advance, but really we'll only know if it works in real time. And so come along with us, see how this goes, and see if this one shot, there's no second New Horizons, there's just New Horizons itself, is going to be able to get it right and reveal this amazing scientific adventure into the past, into the ancient history of our solar system.
All right. Well, Alan, I think that's a great way to step off and tell folks we appreciate you joining us here. I mean, we got to let Alice get back to work and the rest of the team get ready for this flyby that, as of Sunday, is just 100 days away. And New Horizons gets another chance to make more history, flying by something else, another mysterious object that we're all going to see for the very first time. So I encourage you to keep sending questions in through NASA social media to the New Horizons accounts. If we didn't get to them here, we will get to them, either writing them back on the pages or in a different forum. But we're just all excited about being able to tell this story and can't wait to have you all join us on New Year's Eve, where really it's a new year with new worlds and new horizons. Again, I'm Mike Buckley from APL Communications, and for Jim, Alice, and Alan, thanks again for joining us, and keep flying with us.